Okay, it is officially start time. Hello everyone, I'm Anna Heedley and I work as a developer at the Princeton University Library. And I'm just going to talk a little bit about a project we're working on to ingest archival AV materials into Figgy, which is our staff-facing repository application. So Figgy is really a back-end only tool for staff to get materials into our repository and make sure they're all going to look right when they come out into our end user sort of front-facing applications. So this is the fast version about the project in 2 slides. As the story goes so often, we have various kinds of AV handled in various ways, in various systems, and we're finally ready to move it all together into our repository so we can manage it the same way across the board and have some consistency for our staff. So the first set of things we're going to ingest are these archival collections. From an earlier phase of planning, we had tons of documentation from a lot of requirements gathering that have been done. And to make it possible to prioritize for an MVP effort, a minimum viable product for this feature, we narrowed it all down to just one collection to start with. So the archivist who works with that collection became our product owner. And we took our big list of use cases that we had gathered and worked through them with the product owner. In some cases, we could sort of strike whole categories from our initial effort, like access, since this was a collection that had very, very limited access to the public. So that was convenient to narrow the scope on this huge list of use cases. In other cases, like with specific workflow steps and exactly what our ingest requirements were, we still had a lot of use cases in the form of a question. But one thing that did become clear initially was that a lot of the work on this AV project was actually going to be work on the preservation side of our system, because we're working with archives and archivists. And we still had a pretty significant chunk of that to build out into Figgy. So we started working on that piece while one of our colleagues worked on some user interviews and research to clarify the open questions. So the first preservation feature that we tackled was consistent checksumming in Figgy. We added some fields to our resource models to keep track of what the checksums should be and what the when Fixity had been run and whether it was successful or not. We wrote a job to calculate the checksums and compare them to those expected values, and we ran that job right after characterization was finished, and we also set it up to run every time a resource is updated. We also wrote a job that will find the least recently updated object in the repository, run the fixity check on it, and then call itself again. So we kind of have this little process that will chug through all of our resources on an ongoing basis. Yeah, we put that on a new priority queue, which we call it super low, so that those jobs wouldn't eclipse the day-to-day ingest work that needs to happen. Because that job just checks for the least recently updated file set one after the next, that's why we run the fixity check whenever something's updated. I'm not sure we really need to do that, but there's sort of a hypothetical where something gets touched pretty frequently. And if we weren't running the fixity check at that time, there's a potential scenario where it never gets run. Similarly, I'm not sure how well this recursive run it and call myself again job is working. I think we may move toward a cron job that just grabs a certain defined batch and kicks off jobs on those. We're going to hopefully look into seeing how that is doing. So once we had the fixity checks running, we wrote this little fixity dashboard just so that we could keep an eye on it, mostly so that we could see failures as they happened. And it works because we had a few thousand files with bad checksums. It turned out in our own system we were updating those files after the checksums had been computed. So this uncovered a bug there for us, which one of my colleagues figured out and resolved. And we knew we needed to do preservation storage offsite. So another thing we didn't have in place yet, and to power that we wanted to export baguette bags from our Figgy application. This we implemented in the form of a Valkyrie adapter. And so just by virtue of being a Valkyrie adapter, we can round trip these bags, we can write them out, or we can read them back in. All you have to do is tell it where you want the adapter to read and write. And the final piece of this preservation side of this work is figuring out this offsite storage and where we're going to put these bags. This is still a work in progress, but we're in the middle of doing some testing with Glacier. I think the biggest complication here is we need to be able to sort of verify that Amazon is taking good care of the data. So we're doing tests right now about pulling that data back out of Glacier and running our checksums on them again, just to validate that. So while we were working on all that, our colleague Sean did these detailed user interviews and walked through in very minute detail the workflow that the archivists were using to digitize their materials. He came out with this workflow diagram. This is the first half of the diagram. There are 8 steps total. Here's the second half. But here, all of this is before it hits Figgy. These are the steps that are performed by the archivists and the vendors before we even get the files. And they gave us a concrete sense of what we are going to be getting to ingest, which it turns out is baguette bags, and what we were going to find in there. Step 6 here is where Figgy comes in. The plan is to offer a page where they can put their archival collection ID and the path to their bag and ingest it into the system, and then later they can come in and edit permissions and structure and put any finishing touches on their resources before marking them ready to publish. And then this last step is sort of circling back to the finding aid EAD so that they can create this link so that the finding aid knows where these files are in Figgy in order to present them. Sean also came out with some wireframes to guide our development, which were really helpful. This is that ingest screen on the left, and this is a proposed preview screen that is supposed to show the person ingesting how the resources will break out how the files will break out into resources according to the way we've modeled the objects. We haven't gotten to that piece yet, and it's not clear how well that will work. These are the other two wireframes. The one on the left here is the ID report that will support circling these IDs back into the finding EADs. And then over here is an item view page, which imagine that book is a video or an audio file. It's just a picture from a current resource in Figgy, I think. So we've done some implementation. Here's what that ingest screen looks like in real life. You can enter an ID in the file path. Hopefully we will sub in an easier UI here for the file. Some kind of file picker would be really nice. We tried to use browse everything, but you can only get files out of browse everything. You can't get a directory. So I have to figure something else out. There are some validations here. If you hit the create form, but there's already an AV collection that uses that component ID, it will tell you to go edit that one instead. You can ingest more bags once you've created the collection. Like if the vendor had to break up the digitization for some reason into multiple bags, or if you found another box of cassette tapes in the archive that you didn't know about. But if you try to ingest a bag you've already ingested, it won't add it in. Let's see. So once you click save there, it will create an archival media collection. I'm sorry these slides are fuzzy. I hope maybe you can see them better back there. I don't know. Excuse me. But this is just the show page for an archival media collection object. This is just the container for everything that came in that bag or any other bags that you add to it. Figgy kicks off a background job that validates the bag, pulls data from our finding aids API, and parses the collection, the EAD record, in order to correlate the component IDs in the EAD record with the barcodes and the files that are in the bag. So for every component ID that was in the finding aid, it creates a media resource, and files corresponding to the barcodes that were found under that component ID in the record are attached to that resource as file sets. This means that our modeling structure in Figgy mimics the structure on the finding aid very closely. And it makes it easier to have that link circle back from the finding aid into Figgy, or into our model. We also pull metadata from our finding aid site so that we don't have users maintaining metadata in multiple applications, which, as we all know, is to be avoided at all costs. Mostly here, there's just a little bit of collection metadata, the dates, and the, I can't even read it very well, the extent, I guess that is, and the title and language. We also pull the titles for the media resources themselves. Here are some members of the collection. The first collection we did is an audio collection. So you see the little pictures of the cassette tapes here. Each of these is a media resource object, which, as I said, could contain one or more recordings. And this is just because some finding aids will have a section in their EAD structure for each tape in the box, and some will just say, these are the audio recordings of this collection, and then they're just all right in there with a single component ID. Here's a media resource. Each resource has an upload set ID, and that's just given to everything that came in a bag together in case the staff felt like they might need to isolate resources in this way down the line, or if they wanted to do any kind of correction that they found later on or something. So we went ahead and put that in there so we can pull them out that way if that does come up. These are the file set members. This one just has one recording with 2 sides. And you see the little HTML5 player there. It also has an XML metadata file, which comes from the vendor and contains PB core metadata. Mostly we're including that because we're not pulling all of that out and putting it into Figgy, so we want to just make sure it's there in case we decide we need some of that metadata later. The only thing we're pulling out right now is transfer notes, which say things like, there was a lot of hiss on this recording, or that kind of thing, or this side was blank. And then there's the photograph that the vendor has taken, which we use as a thumbnail. Here's a file set list for a media resource where the title was audio cassette recordings. So this is just what that looks like when they're all in there together. There's a big group of the recordings, and then a big group of the XML files, and then a big group of the thumbnails. So here's a file set. The transfer notes are here, and then the files are below them. We have an MP3 derivative file, an intermediate file, and a preservation master. And in our case, all of these came from the vendor, and we just uploaded them all as part of the bag. So we're not doing any derivatives creation or transcoding as yet. Here's the report. Oh, this is just a link to the report page. So at the bottom of the collection, you can view everything in the collection, or you can go to this little report. It lists the persistent IDs and the finding aid IDs as promised, and there's a little CSV download feature. And that's basically where we are so far. I imagine, this collection was a really great way to get started because there were big pieces that we didn't have to deal with all at once, like transcoding and the IIIF AV manifests and compliant viewers. But that's definitely all part of our future work. So because of the permissions that are often attached to archival collections, we know that we're going to have to do IIIF auth, which we haven't done yet. So that will be a big piece of our future work. Otherwise, and to lead that work, we'll be selecting a second archival collection to load. We're going to work with a new product owner on the collection, so we start moving out to get different perspectives and see where we need to make our workflow more generalized. We're going to start migrating an archive of music performances as well, which will probably also need new features. There are some other use cases that we know about that we'll have to deal with. For example, archives, it's possible that they will just get completely reorganized. So we are going to need to be able to change component IDs, and especially with those cases where it was just a list of all the audio cassettes that were in a box. The archivists are going to want to probably break those down into smaller chunks within their EAD records. So that will have to happen in Figgy as well to keep that modeling consistent between the two places. And even if they're not going to break them down, they're probably going to want to organize them if they ever want to show them to somebody. To put them in a logical order. And another thing we're working on is figuring out a plan for captioning some of this stuff, transcribing some of these audio files, both creating those captions and transcriptions, and then also presenting those to end users. And that's what we got. So we do have time for questions, but definitely also interested in just hearing from other people. If this brings up thoughts of what you're working on, or if you're thinking about the same kinds of things, I'd be interested in hearing from you as well.
Actually, I have two questions, but I can sneak both in. Figgy is Valkyrie and Blacklight, is that what you're stating?
Yeah.
Not Pyrex?
Correct.
Okay. So quickly, was it difficult to incorporate Valkyrie and Blacklight? Do we know, like, or was it relatively trivial? Were there any specific challenges that had to do with the fact that you were using Blacklight and Valkyrie together? I guess that's question one.
I mean, this piece of work is really just slotted right into the application. So where it touches Valkyrie is mostly in the way it persists things through change sets. But that's just part of the way we work in Figgy all the time. So it didn't feel particularly special. In other, mostly this was like writing any sort of Rails process, right? So I wrote an active job and I called out to various helper classes to do, backit validation, backit parsing, and all the various types of data munging functionality that was needed. I'm having trouble identifying exactly what you mean when it comes to the Blacklight piece, because...
Yeah, well, specifically, so if you have experience with Pyrex or Micro or Curation or whatever, Active Fedora basically manages the persistence and the index. Like you hit save and it goes to both, right?
Yeah, Valkyrie does that also.
Valkyrie does it also, but I'm looking at the code and you wrote a custom indexing, whatever they call it, persistor. So my thinking is like that index persistor that is pushing things into Solr is kind of doing the same thing that some of that hidden code from Active Fedora used to do. And I was just wondering, did you have to write that from the ground up? Was it hard? Does it have to take into certain Blacklight considerations? Like, do you have to make it Blacklight compliant when you do that?
Yeah, we use the Blacklight schema conventions when we push fields into Solr for sure. That class that you're talking about was around before I came, but it's pretty simple and straightforward. And in fact, if you need to write a class like that in a Valkyrie app that you are developing, there are examples on the Valkyrie wiki that you can basically probably just pull into your application.
Cool. And then real quick, did you consider anything other than Glacier when you were doing your considerations? I know somebody had said something about not trusting Glacier. I was wondering if did you just settle on it by de facto, or
Yeah, we did some sort of prospective guess pricing out of Glacier and the Google equivalent, and I think we'll probably do some testing with that as well. We're not settled on exactly what we're going to do. I think we're messing around with Glacier first because we have some campus IT agreements with Amazon. And the lack of trust of Glacier isn't because it's AWS, it's because I think archivists are just kind of trained to not trust a statistic like 11 nines. There's a real need to see when was this last checked? What has been checked? Are you checking everything And if so, on what schedule? Are you just checking some sample of my stuff? And if so, how often? And there's a real desire to care for each individual file and know that each individual file is being cared for. And none of these services are going to provide that. So that's why we're looking at pulling data back out and running our own checks on it so that we can have that I can touch it and feel it assurance, even though we'll probably have way more errors due to pulling it over the network than we would just from letting it sit in the meter.
Let me preface my question with another question, and perhaps someone here knows, is Glacier actually tape storage?
It's not.
We don't know. Okay, so then if that were the case, hopefully not, I don't know. Every time we run a check, are we risking wear and tear on those mechanical systems, which Amazon may or may not be using?
I mean, Francis is shaking his head no, so.
Just pass
Good
it
enough
back
for
to
me?
Francis.
I don't think,
It's on.
I don't think we can try to reverse engineer what it does. We know it's block storage. We believe it's in ingest. And that's, and then we trust the Amazon API to do, certain activities. So no, I don't think there will be wear and tear because Amazon cares about that. But that's all standard. I don't know how bad it is.
And just to follow up on the trust issue, it's not that we distrust Amazon particularly, it's just that when they talk about reliability guarantees, and I've heard from people at the Texas Digital Library that have gone and done a lot of work trying to get more details out of them, they just will not be specific enough to satisfy us and our users. And so we don't have enough information to trust them.
A couple of my colleagues went to the Library of Congress storage meeting a couple of weeks ago, and there were representatives from Amazon there. And they came back and did say that currently Amazon is storing on tape. And that is why it takes a while to pull the files down, and they're going to start creating a new pricing tier. So if you really want your file within an hour, this person's going to rush and go pull the tape. And if you want it within 12 hours, it'll cost less.
And to address the multiple story, Google Cloud Compute is on spinning disk. It'll come back real quick.
Yeah.
So, and we will be testing that. OIT's agreement with Google is much harder to do testing. So,
I'm just I was backing up, sort of going through similar analysis on Glacier and how to do it. So you're going to write a service that pulls back from Glacier and then runs a Figgy check. Did you guys do any pricing on scaling there?
That's what we're in the process of doing right now.
Whether it's just better to keep it in S3 because you don't have to pay the cost of pulling it back.
Right.
it won't copy.
Exactly, yeah, okay. And you also, a follow-up, you're also planning on just sampling to make the archivist happy, so like you're saying, generally it's.
I don't think that's going to make.
No,
that's
you're
not
gonna try to
gonna-
do everything else. I don't know, some of the, it's not.
For your round trippable maggots, what format is the metadata serialized
Probably JSON. So Trey wrote that, so I
in?
don't.
Okay, I guess that's good. I guess as far as the Glacier, if you actually are doing regular Fixie checks, doesn't that eliminate any cost savings in Glacier? Because you have to pay to retrieve it to the Fixie check?
From our initial analysis, it doesn't eliminate the cost savings, but again, it's one reason we're trying it out. I mean, it eats into them for sure. We had time?
I think we're at time.
Great, thanks all.